Hi everyone, this is Dr. Orkun Bajik, and today we are going to talk about probability. Okay, so I'm going to explain this topic with an example because I think that will work the best for this particular chapter. So let's say that we analyzed a data set about 500 homes that were purchased last year in a particular city. And we observed that 300 of these homes were a two-story home and the remaining 200 were a one-story home, okay? We also know that 175 of these two-story homes have a garage and 50 of the one-story homes have a garage, okay? We randomly select one of these homes and we have a number of questions to answer based on this example. So the first one is to list the events given in this problem description. So defining your events is the most important step when you answer a probability question, okay? So I'm going to list my events here and I will have 4 of them, okay? The first one is going to be, let's say it is T. Event T is the event that the selected home is a two-story home. Okay, so this is my first event. And the second event could be that the selected home, let's fix the typo. Selected home is a one-story home. Okay, so I'm going to define it by using the letter O. So T is the event that the selected home is a two-story home, and O is the event that the selected home is a one-story home. And we also have some data about the home having a garage or not, right? So I'm going to define this other event, G, event that the selected home has a garage. Okay? So I copy and pasted, and the second one will be that the selected home does not have a garage. Okay, so I have 4 events, the home being a two-story home or a one-story home or having a garage or not having a garage. Okay, so 4 events. So this is the answer to part A. What is the probability that a selected home is a two-story home? So here's the thing. There are multiple ways to answer questions like this and the following questions, but what I like to do is I like to summarize what is given in the question in a table. Okay, so I have a table on the left-hand side of the screen, and what I'm going to do is I'm going to input all the numbers that I already know into this table, and I will use those to answer the questions. Okay, so here's how I organize this. I listed the types of homes, and I also listed the home having a garage or not. Okay, so let's see the intersection of this. So this cell corresponds to the intersection of the home being a two-story home and having a garage. How many of such homes do I have in this 500 homes? So that is going to be 175. Okay, so the question says 175 of the two-story homes have a garage. So this is 175. 300 of these homes are a two-story home. So the total is 300. And if 175 of them have a garage, how many of them don't have a garage? The answer is going to be the difference between the total number of two-story homes and number of two-story homes that have a garage. So that difference is 125. How many of the one-story homes have a garage? That is 50, right? 50 of the one-story homes have a garage. So 50 is the number of one-story homes with a garage. How many total number of one-story homes do we have? And that answer is 200, right? So 200 of them are a one-story home. So the difference between these two values will give me the number of one-story homes with no garage. Okay? So total number of homes with a garage will be equal to 175 plus 50. And the number of homes without a garage will be 125 plus 150, and the total number of homes is equal to 300 plus 200, which is equal to 500, as we would expect. Okay, so I listed and summarized every single number that I already know. Okay, and these will be very helpful to answer these questions. So let's look at part B. What is the probability that a selected home is a two-story home? So here's a question. Two-story home. So how many total number of two-story homes do we have? 300, which is given in D2. And how many total number of homes do we have? 500, right? Which is given in D4. So the answer is going to be the number of two-story homes divided by the total number of homes, which is 0.6. Okay, so this is the answer to part B. Part C, what is the probability that a selected home has a garage? So the home having a garage is an event that we defined by event G, right? So we are going to look at how many of these homes have a garage. That is 225, right? The total number of homes with a garage, divided by the total number of homes that we have, which is 500, right? So that will be 0.45. Part D. What is the probability that a selected home is a two-story home that has a garage? So how many events do we have in this question is the first question that you will need to answer. And the answer to that question is 2, because we have the event that the selected home is a two-story home and the event that this home has a garage. So the notation for this will be T intersection G, okay? So the intersection symbol is given here, T intersection G, which is also called the joint probability of T and G. The answer to that will be, how many two-story homes with a garage do I have? The answer is 175. And how many total number of homes do we have? 500, and that will give you the answer that we are looking for, okay? 0.35. Part E. What is the probability that a selected home is a two-story home that does not have a garage? How many events do I have here? So let's copy and paste this previous one because it's very similar, right? In this case, I have 2 events, the home being a two-story home, but in this case, we are looking at the homes that don't have a garage. 2 events, but this time, no garage case. So this G can be replaced by N, which is the event that the selected home does not have a garage, okay? So how many two-story homes do I have that don't have a garage? The answer is 125, which is from cell C2. And how many total number of homes do I have? 500. So the answer is 0.25, okay? F. What is the probability that the selected home is a two-story home given that we know it has a garage? So this is a different type of a probability question, okay? The keyword here is given. And when you see a question like this, that is a conditional probability question. And what that means is one of the events is conditioned on another event. So let's write down the notation for this event. So the notation will be the probability of T given G. Okay, so the probability of T given G. So what is the probability that a selected home is a two-story home given that we know it has a garage? So the notation will be T given G. And the formula for this is the intersection of T and G, or the joint probability of T and G, divided by the probability of the event that we already know about, okay? So this is the formula. So the joint probability of these 2 events divided by the event that is given, okay? So the joint probability of these 2 events we already calculated in part D, divided by the probability of G, which we calculated in part C, okay? So the answer is going to be 0.77. Okay. Part G. What is the probability that a selected home is a two-story home given that we know it doesn't have a garage? So it is similar. Let's copy and paste and modify. Okay, so this is part G. This time we know that the home doesn't have a garage. Therefore, this G will become N. So the joint probability of T and N, and divided by the probability of N. Okay? Do I know the joint probability of T and N? Yes, from part E, I know that answer. And do I know the probability of N? I don't know now, but I can calculate it, right? So that is the homes that don't have a garage, which is 275, divided by the total number of homes. Okay? That will be 0.45. Again, the formula is given here. Make sure that you use the parentheses correctly and you will get the answer of 0.45. The last question is about independence. We have two events. The first event is the event that the selected home is a two-story home, and the second event is the event that the selected home has a garage. Are these two events independent? So to answer a question about independence, there is one formula that you can check. And that will be if the joint probability of these two events equal to the product of their marginal probabilities. Okay? So the joint probability of T and G, because the first event is actually event T and the second event is the event G that we defined. If the joint probability of these two events is equal to the product of their marginal probabilities, so PT times PG, then you can say these are independent. Okay? So let's look at this calculation. The joint probability, we know the answer from part D, it is equal to 0.35. So let's look at the product of the marginal probabilities. The probability of T is given in part B, so 0.6 times the marginal probability of G, which is 0.45. Okay? So the product is equal to 0.27. Are these two values equal to each other? The answer is no. So our conclusion will be T and G are not independent. Okay? If they were equal to each other, we could conclude that they are independent, but if they are not equal to each other, they are not independent. Okay? So this will conclude this reading, and I will see you in the next one.